Today we're talking about limits of exponential functions. Mostly what happens as the limit goes to infinity, right? Negative infinity and positive infinity. So as you can see by these four graphs, we're going to be hopefully making some general statements that will help us apply it to other situations where we don't have to have the graph. Like if you're not allowed a graphing calculator, or if you just have no idea what it looks like. So let us talk about what these things are to begin with. So our first example, is this an exponential growth or an exponential decay function? Decay. It is a decay function. Okay, but looking at the graph, of course, it's getting smaller as it goes from left to right. And looking at the equation, how can we tell it's a decay function? No. This ratio, right, the thing in parentheses, that's your ratio. The ratio is less than 1, which means every x is going to be 2/3 of the previous x. 2/3 and then another 2/3 of that and 2/3, right? We're getting smaller and smaller and smaller. So if we're looking as x goes to negative infinity, that's the left side of our graph. What is the graph doing?
It's increasing by positive a.
So its limit is going to be positive infinity. To the left side of the graph, I guess the left side of the grid, the graph is going up to positive infinity. And what is it doing on the right side of the graph? It's approaching -2. And what would -2 be for this exponential function? The horizontal asymptote. Okay, that's going to be key here as we start doing a lot of these problems. On one side, it's going to go into infinity or maybe negative. And on the other side, it's going to go to its horizontal asymptote. So looking at the graph, our next example is what type of a exponential?
A growth.
A growth function, and you can tell because the ratio is greater than 1. So this is an exponential growth function. Okay, as x goes to negative infinity, where are the y values getting close to? -2. Once again, the horizontal asymptote. And as the graph goes to the right of the grid, it's going to positive infinity. Okay, so exponential growth, right? As x's get really, really large, the y values get really, really large also. Okay, and x gets really, really small, the y values go to whatever that horizontal or that limiting factor happens to be. The smallest is going to be -2. So we have a growth and we have a decay. And what about this next one? Is this growth or decay? It's decay, and it's actually a negative decay, isn't it? Because there's a negative in front. Okay, the negative is going to play an important role here in a little bit. So this is a negative decay function. Okay, so to the left, what is the graph doing to the left of our grid? Going down to negative infinity. Our negative decay goes to negative infinity on the left. And on the right, once again, it's going to that horizontal asymptote at -1. Okay, so hopefully maybe we're able to see some generalities here about where these things are approaching. Okay, example number 4, growth or decay. This is actually a negative growth function. Right? It's getting really, really large in a negative direction. So what I want you to notice is we have a fraction raised to a negative power. Okay, and whenever we have a fraction raised to a negative, we can pull out the negative from our unparenthesis, make it an x -3. Okay, and this is just the exponential part. So then if I have a fraction raised to a negative, that becomes a reciprocal raised to the positive. Okay, so if we ever have a fraction raised to a negative power, that is still a growth function. And then because there's a minus out front, that's what makes it go down and makes it a negative growth. Negative growth. So to the left for our negative growth function, the graph is approaching
2.
positive 2, right, the horizontal asymptote. And as x goes to infinity, to the right, the graph is approaching negative infinity. Okay, so looking at our potential answer choices, what are the 3 choices that we can have? There's only 3 of them. One of them is positive infinity, or negative infinity, or our third option, the horizontal asymptote, whatever that happens to be. So can it be 0? Sure. Okay, if there's no plus or minus, right, this is your vertical shifting. If there's no plus or minus after your exponential function, then it can have a limit of 0. It can approach that x-axis as it gets really big or as x gets really small. Okay, so the 4 rules for determining if it will be growth or decay. So a growth function, undo that. What does our ratio have to be in order for it to be growth? Greater than 1. A ratio greater than 1 is definitely a growth function. Okay, what else could happen in order for it to be a growth function?
If there's a negative exponent.
Okay, so we have a fraction less than 1, right? Some fraction raised to a negative exponent. That is also a growth function. Okay, so in those 2 cases, we're going to get exponential growth.
What if it's something over 1 that's raised to a negative?
So then decay, an exponential decay function will have a ratio between 0 and 1. Or we could have a decay function if we had a number larger than 1, but raised to a negative power also.
Wait, so a decay can be at like a negative number, or it can?
So here are our general statements that we want to get from this whole exercise. Okay, if we have an exponential growth function, okay, and we're taking the limits as x approaches negative infinity of our exponential function, the answer will always be the horizontal asymptote of that function. And then the limit as x goes to positive infinity, right, has 2 options. If your function is positive, then your limit is positive infinity. And if your function has a negative in it, right, I guess I should maybe write it like this. Let's erase all this real quick. If negative. Okay? So that's for our growth. If you're going to the left, your graph is going to the horizontal asymptote, and if you're going to the right, it's either getting bigger if it's positive or getting smaller if your function is negative. Okay, and similarly for a decay function. Okay, as you go towards negative infinity for a decay function, this is where you have your 2 options. Okay, it's infinity if you have f of x is positive, and it's negative infinity if you have a negative exponential function. So look out for those negatives in front. And then the limit as x goes to positive infinity of an exponential decay function will once again be the horizontal asymptote for that function. Okay, so these are our general statements that we're going to make based upon our graph. So let me get some problems so we can look at them together. So let's see if we can apply those general statements to these functions. Okay, so the first thing we have to do is decide, is this a growth or is it a decay? And then is it going to positive infinity or negative infinity. Okay, so number one, we have 2/3 raised to the negative of x minus 1. So hopefully you know that we can rewrite this as,
3/2 to the positive, to x plus 1, right?
yeah, so we're going to write 2/3 to the negative of x plus 1 power.
Yeah.
Right, well, still taking the limits of this as x goes to infinity. Right, we're being very formal here. So now that I have a fraction raised to a negative, I'm going to flip it into a, right, take the reciprocal and make it 3/2 raised to the x plus 1 power minus 2. And we're still talking about the limit as x goes to infinity. So we have an exponential growth function that's going to infinity, right? A positive exponential growth function that's going to infinity.
So it has to be infinity.
So the limit will be infinity. Okay, a positive exponential growth function going towards positive infinity. The y values are getting infinitely large, so the limit is positive infinity. Okay, the limit of our function equals infinity. Okay, the function itself doesn't equal infinity, it's the limit. So all of this has to be here for calculus. On your FRQs, you have to write this exact thing over and over. Okay, let's look at the one to the right. Okay, is this a growth or a decay function?
It's negative growth.
A-
No, it's negative decay.
This is a negative decay, right? It's a negative, so that makes it negative, right? The minus in front. And then it's a ratio less than 1, right? 0.4 is 4/10. Makes this a negative decay function going to negative infinity, right? That's what our limit is. The limit as x approaches negative infinity.
So it's this negative infinity.
So this answer is negative infinity. It's a negative decay function going to negative infinity, and the limit of one of those is negative infinity. Okay? Pretty not too bad, huh? Maybe? We'll see. We'll see how you do. Okay, how about down here, number 7? We're taking the limit of an exponential, but it's going to a number. So this is just a direct substitution problem. E to the 2 minus 3 plus 2. Direct substitution. You only have to make a determination whether it's growth or decay if it's going to infinities. But here we're going to a number, so it's just direct substitution. E to the negative 1 plus 2, which is 1 over e plus 2, which would probably be just fine if you left it like that. Okay, that is a perfectly good answer. Or if you want to be cute, you could write it as 2 and 1 over e. Right, like if this happened to be a 1/2, 1/2 plus 2 is 2.5. Well, this is 2 and 1 over e. But that's just, calculus will be fine if you left it like that. Okay, so if you have a limit going to infinity, you have to decide whether it's a positive or, a growth or a decay, and then whether it's positive or negative. Okay, your answer is either a horizontal asymptote or it's one of the infinities. So hopefully this has been helpful, and now you know everything there is to know about limits of exponential functions.